Hello guys, welcome back. This is part 13 of the Metasploit Mega Primer. In this video, we will look at two very interesting and important concepts of post-exploitation, which are pivoting and port forwarding. And we will do both of these using Metasploit. Right, so this is phase 6, using the victim as a pivot to hack deeper into the network. Now, what exactly is pivoting? Now, let's look at a sample scenario in which there's a firewall and a server 1 is behind that firewall. Then there's another firewall and server 2 is behind that firewall. Now, as many of you might probably recollect from networking basics, this zone is called the DMZ, right? So this is one of the cases in which the attacker may not be able to reach server 2 directly, right? But he may have access to server 1 because server 1 may be offering some services which may be allowed through the firewall. That is the first one, right? So how does pivoting actually work? The attacker first goes ahead and compromises server 1, to which he has direct access to, that is IP level connectivity. Once he breaks into server 1, he uses server 1 as a staging point for further attack into the network and then breaks into server 2, right? So think of pivoting as a technique using which an attacker can break into machines much more deeper into the network, to which he might not have direct access from where he is stationed currently. Right? So the pivoting attack demo. Now we've taken a sample scenario in which there is server 1, which has two interfaces. Think about it this way. One of the interfaces is internet facing and has an IP address 192.168.1.232. And the other interface has an internal IP address 10.10.10.100. Now in that internal network, there is another server 2, having the IP address 10.10.10.150. The attacker is on the internet and can get IP level connectivity to server 1 but not to server 2. Right? So this is the sample scenario. So now what we will do is, first we will attack server 1, break into it, and then go ahead and use server 1 as a pivot to break into server 2. Right? So let's go to our demonstrations. One quick point, server 1 in this scenario is a Windows 2003 Server Enterprise Edition, and server 2 is a Windows XP machine, right? So this is your server 1, which is your Windows Server 2003 Enterprise Edition, which is accessible and probably running a service. And this is server 2, which is your standard Windows XP machine, right? Okay, and this is the attacker machine running backtrack. What we've done is we've connected to this attacker machine using PuTTY so that I can probably get a full screen and talk more about the exact process without worrying about the screen size, right? So on server 1, we will break in using a client-side exploit, which we've demonstrated a couple of times, but we'll do that again from scratch. This is the attacker's IP address, if you remember the presentation, right? Port to be 80. I think by now you must be familiar with what I'm doing, because the same demonstrations I've done multiple times using browser vulnerabilities, right? We wait for the different exploits to get loaded. In the meantime, we'll quickly confirm that server 2 basically contains two IP addresses. One is 10.10.10.100, which is probably for the internal LAN, and the other is 192.168.1.232, which is facing towards the attacker. Of course, we've taken a sample scenario simply because even the 192.168 space is a private address space, right? So, but anyway, just for illustration purposes. Now what we do is, we'll go ahead and access the attacker machine, right? And this will go ahead and trigger our client-side exploit. So this is the first step while the attack is going on, where we are actually breaking into server 1 because we have direct access to it using a client-side exploit, right? Let's go back. Now a Metasploit session has been opened. Awesome. And we've also migrated to another process, right? So if you have a look at the available sessions, we have one Metasploit session available currently. And we've migrated to another process as well. So let's connect to this Metasploit session. Great. So now the second task before we move in is actually at this point we do not know exactly what are the different IP addresses present on this computer. So let's do an IP config. And we notice that the 10.10.10.100 domain is basically, sorry, the 10.10.10.100 is an IP address also assigned to this computer, which means there probably are many more IP addresses and machines in this range. So how do we go about finding this out? Well, we'll use one of the Metasploit scripts called Arp Scanner. It's a very interesting script. And what we will do is we'll actually tell it to an Arp scan, which it does using Arp requests, to figure out which machines on the same subnet are up. So let's go ahead and give it this subnet, and let's see what results we get. So now using Arp scanning, we are very quickly finding out which machines on the subnet are up and running, right? This may take a while. Probably pause the video to save some time, or maybe not. Right? Let's give it a minute. So this is the way after you break into server 1, you can actually go about finding other machines which are behind it much deeper in the network, to which you as an attacker will not have direct access to, right? Awesome. So it's already found two IP addresses. This of course is our own IP address, which is server 1's IP address, and this seems to be another IP address which is up and running, right? So if you remember, one of the first things we need to do is run a port scan on this computer. But how do we do it? Currently, the attacker machine can only access server 1 and not server 2, right? So this is the case where we are going to set up pivoting. What we will do is we will actually set up a pivot where we will go ahead and tell Metasploit that any packets the attacker is sending for the 10.10.10 network should actually be sent via server 1 and basically via the Metasploit session which is already established, right? How do we do that? Well, quickly let's first background the current Metasploit session. Now we use a command called route, and route basically has a very simple format. We say route add, go ahead, we mention the subnet, sorry, this is the 10.10.10 subnet and the net mask. After that, we go ahead and give the Metasploit session ID, right, through which to route all traffic for this network to. Now, this, if you remember, was 1. This is the current first Metasploit session to which we connected a while back, right? Metasploit session 1. This is the session through which we want to route the traffic. Let's hit enter and let's quickly do a route print. So now if you notice, what Metasploit will do is that all traffic which we want to send to this network will actually go through session 1, which is nothing but the Metasploit session which is established on server 1, which we have broken into currently. So let's actually try and use a port scanner. We leverage one of the auxiliary modules and use a port scan, and we'll use a TCP scan. Now, one of the things you need to remember is we cannot send arbitrary packets through this pivot. Only packets which can be sent are ones where we are actually bound to a port, which means a legitimate connection needs to be made. You cannot do a SYN scan because SYN scan basically is not a full connection. There is no port which is bound anywhere on the client or on the server side, right? So raw sockets, if you use and if you send packets, that will not go over this session. So always remember that, very, very important, because if we had used the SYN scan, it would not work. That is why we are using the TCP scan. Anyway, let's quickly look at the options. One of the important things we need to set is the R hosts. We already know that the IP address which we found there is 150. And I think what we'll do is we'll go ahead and set the ports range between 1 to 100, right? This is where most of the interesting ports generally are on Windows machines. Actually, not 1 to 100, we'll make it 1 to 200, right? Awesome. And now let's run the port scan. So if you notice, now from the attacker machine, we are able to figure out the ports which are open on server 2, right, which is here. And all our port scans are actually going via server 1 to server 2. Awesome, isn't it? Very beautifully done by the Metasploit team. Congratulations to them for such a great tool which they've written. So if you notice, DC RPC seems to be open on the remote host, which is server 2, having an IP address of 10.10.10.150. So what we will do right now is we will go ahead and try and check if we can break into 10.10.10.150 using the DC RPC exploit, right? So we go back, select an exploit, Windows, and the 03026 DCOM exploit is our favorite. Look at the different options. Need to set the R host. In this case, it is 10.10.150. You'll also need to set a payload in this case. Now, one important thing to note is the payload which we can set without which will actually work properly without making any other modifications or changes would be the bind TCP form. Because here is the issue. If we do a reverse connect, then there is no way server 2 can actually reach the attacker machine. Now, the way you could do it probably is by enabling some sort of port forwarding on server 1. But we won't get into that complexity as of now. We'll discuss port forwarding separately a little later in the same video, right? So for the time being, the payload which we will set is going to be a Metasploit payload, of course, but it will be the bind TCP form, right? Let's look at the options. Everything looks good. Now let's go ahead and exploit this host. Awesome. It almost looks as if we are done. So all the traffic to server 2 is now going through server 1. Awesome. So if you notice, we have Metasploit session 2, which is now open. Now quickly look at what is being said here, right? If you notice, it actually says, well, 1.10, which is the attacker machine, is connected via 1.32, which is server 1, finally to server 2, 1.150, sorry, 10.150, right? And if we actually background this Metasploit shell and do a sessions-l, we'll notice there are two sessions now. The first one, of course, is to server 1, and the second one is actually to server 2 via server 1, right? Great. So let's actually connect to the second Metasploit prompt, do an IP config, and you would notice that yes, we are on 10.10.10.150, which is the Windows XP machine, right? Great. So now, as you can easily understand, we can go ahead and do anything on machine 2, and it'll almost exactly be as if we are on the same machine, because whatever we are going to type in here is going to get routed via server 1. And all this happens very transparently. There is nothing else you need to set up. And this is the power of pivoting. Now you can imagine from here, we can actually break further into the network, into other machines. And this can just go on and on. I mean, I'm almost tempted to write a worm using Metasploit. Imagine a simple script which actually tells Metasploit to break into a computer, then checks the local interfaces for other subnets, finds a new subnet, scans that subnet, finds victims, run autopon, break into new victim, once again run the same script, which is find more subnets, more computers, run autopon, break into them, and just go on and on. And I can imagine it shouldn't be too tough to go ahead and write such a script, right? So let's go ahead and exit this Metasploit one, because in the next demo we'll talk about port forwarding. Now we are back to just one session, which is to server 1, right, which is the Windows 2003 server. Let's go back to our presentation and look at the next concept. Now, before that, I'll just get your attention on something. When we actually ran the port scan, if you noticed, port 80 was open on server 2, which would actually mean that maybe there is a web server running on that port, which may be running an intranet web application, which would be very interesting for us, because this might house a lot of interesting data, right? So what we are going to try to do is somehow from the attacker machine connect to this web server, but using a browser. Now we know using Metasploit, definitely we can try and exploit the web server using different vulnerabilities, depending on whether it is Apache, IIS, WebSphere, or something else. But now what our challenge is that we need to be able to surf the intranet web application from the attacker machine itself, even though he does not have direct access to the 10.10.10.150 web server, right? So with this background in mind, let's go back to the presentation and look at a new concept called port forwarding. So what is port forwarding? Well, very simply, the attacker first breaks into server 1 and establishes a Metasploit session. Then what he ideally wants is to reach a particular port on server 2 so that he can try various activities like surfing an intranet web application, or trying to go ahead and do some other exploitation or something else for that matter. Now, how would he do that? Well, the first thing we can do with Metasploit, which I'll just demo in a minute, is create a local listener on the attacker's machine itself. Now, when any application like a web browser talks to this local listener, then this local listener will forward all that traffic to server 1 where our Metasploit session is running. Now, once we enable port forwarding on server 1 using Metasploit, we will be able to reach server 2 via server 1. So the whole idea is that now via port forwarding, applications on the attacker's machine forward data to a local listener on the attacker machine. This local listener forwards all the data to the Metasploit session, which goes ahead and forwards all the data to a destined port on server 2, right? So basically server 1 acts as a relay. Now let us look at what is the demo here. So what we are going to do is first break into server 1 using the Metasploit session, which we already have, and that is the Metasploit prompt we are on right now. Then we will set up port forwarding here to ensure that any data sent from the attacker's machine to his local port 25,000 will be forwarded to server 1 and via server 1 to port 80 on server 2. Right? So the most important thing with port forwarding in Metasploit is the local listener is running on the attacker's machine. It is not running on the server. Remember that. It's a common mistake people make. The local listener is on the attacker machine from where data is forwarded to server 1, from where it is forwarded to server 2's whatever designated port we've set port forwarding on. Right? Awesome. Let's go back to our Metasploit prompt. So basically, we are here. If you look at the sessions, we have one Metasploit session, which is basically on server 1, right? So we have a Metasploit session here. What we are going to do is connect to this Metasploit session. And then we will go ahead and set up port forwarding. Now, what do we want? We want that all data which is sent to port 25,000 on the attacker's machine should be forwarded to server 2's port 80 so that we can figure out if there is a web application running, right? So we use the port forward command. Let's do a -h to figure out the exact syntax. So port forward add. The local host to listen on, of course, is going to be our own machine, which is the attacker machine. The local port, as we have mentioned in the presentation, is 25,000. The remote port is going to be 80, and the remote IP address is going to be the 10.10.150 IP address, right? Which is basically of server 2. Now, if you notice, it confirms that a local TCP relay has been set between 25,000 to port 80 of 10.10.150. Now, because we have already set a route, let's background this. Because we have already set a route that any data for the 10.10 network should be forwarded via session 1, the whole relay happens transparently, right? So now we've set up this port forward. Now what we'll do is we will use a browser to access port 80 of 10.10.150 by actually going ahead and sending a request for this IP address, right? Which is localhost 25,000. So we have our backtrack instance running here with the web browser already open. Let me go ahead and type in the URL. The URL, of course, is localhost, and then we have 25,000. Awesome. If you notice, we are now able to access the web server which is running on server 2 via server 1. And we can go and access any of these scripts which are running there and actually look at what the intranet application actually contains, right? So this is the power of port forwarding, where what we can actually do is, if you go back to our presentation, create a local listener and have all traffic sent via server 1 to server 2's any port. Now this can be very beneficial because you may want to run a lot of other tools on the attacker machine to check what is happening on the on server 2 from the attacker's machine. And many of these functionalities Metasploit itself may not have. So there is no way you can actually run the command from within Metasploit. And this is where port forwarding becomes very, very handy. Right? So if you notice, we've actually gone to the login prompt, and people who are familiar with web application security know that probably I may be able to break into the remote web server using an SQL injection flaw, right? So this is a way by which the attacker can actually go ahead, use port forwarding and access internal services on the victim's network, right? Very powerful. Awesome. I've broken in using SQL injection, right? And all of this is happening on the remote Windows XP server, which is actually running the web server, Apache, MySQL, everything, and is hosting the vulnerable web application. Right? So that's all for this video. I would really encourage you to try both pivoting as well as port forwarding. And like always, a humble request to leave behind your comments and feedback. I'm continuously looking to improve, and it is your feedback which helps me do that. Be rest assured I'm taking note of each and every comment you make, and I will go ahead and add a lot of these in the future videos. That's all for this video. Signing off. Bye-bye.